Now, in order to draw the correct Lewis structure, it's important to follow the outline for drawing Lewis structures. And this starts with the molecular formula. And we use the molecular formula to count the total number of valence electrons in the molecule. The next step is to draw the skeletal structure for the molecule. And atoms with the lowest electronegativity are placed in the middle of the molecule. Hydrogen atoms and more electronegative atoms are placed on the terminal ends of the molecule. Next step is to distribute our electrons, and in general we place 2 electrons in each chemical bond, and the remaining electrons we distribute as lone pairs. And we give each atom 8 electrons to form an octet. In the case of hydrogen, we give each hydrogen atom 2 electrons to form a duet. Okay. We add the lone pair electrons to the terminal atoms first, and then place any remaining electrons on the central atom. The next step is to check that each of the atoms has an octet, and then we form multiple bonds as needed by turning lone pair electrons into bonding pairs. Finally, we check the formal charges and follow the rules for formal charges to select the best Lewis structure. And this will lead us to the correct Lewis structure. The octet rule states that atoms will prefer to gain or lose electrons in order to attain 8 electrons in its outer orbitals, which corresponds to a complete or filled valence shell. In order to check whether an atom obeys the octet rule, we first count the number of electrons in it, where each lone pair represents 2 electrons and each covalent bond also represents 2 electrons. Now it's important to remember that the octet rule only applies for carbon, nitrogen, oxygen, and fluorine. While the other elements in the product table can sometimes obey the octet rule, they don't necessarily have to. In this example, we are asked to write the Lewis structure for NF3, or nitrogen trifluoride, which is a colorless, toxic, odorless, and non-flammable gas that is used as an etchant in the microelectronics industry. Now, in order to write the Lewis structure, we'll have to start with, number 1, the molecular formula for the compound, in this case, NF3. From the molecular formula, we will have to count the number of valence electrons in the molecule. And then, we will write the skeletal structure of the molecule, and then we will distribute the valence electrons to write the correct Lewis structure. Now, you should recall that nitrogen, being a group 15 element, has 5 valence electrons, and fluorine, which is a group 17 element, has 7 valence electrons. And since there are 3 fluorine atoms in our molecule, we have 3 times 7, which is 21 valence electrons for the fluorine atoms. Adding them all together gives us 26 valence electrons in our molecule. Now, in order to write the Lewis structure, or the skeletal structure, we should recall that nitrogen is the least electronegative element in the molecule, and so therefore nitrogen is the central element. Fluorine, being more electronegative, forms the terminal atoms in the molecule, and so our nitrogen atom is surrounded by 1, 2, 3 fluorine atoms. The next step is to distribute our valence electrons. And the first part of this is to connect our atoms with bonds, like so. And so we have 1, 2, 3 bonds, and each bond is formed from 2 electrons, and therefore we have 2, 4, 6 electrons. Now we have to add lone pair electrons to our molecule, and we first place those on the terminal atoms, giving us 8, 10, 12, 14, 16, 18, 20, 22, 24 valence electrons, leaving us 2 valence electrons left to distribute. And we place these valence electrons on the central atom. In this case, is nitrogen. We can see here that both nitrogen and fluorine obey the octet rule. For the fluorine atoms, we have 2, 4, 6, 8 valence electrons, giving us an octet. And for the nitrogen atom, we have 2, 4, 6, 8 electrons, also giving us an octet. And so this is the correct Lewis structure for nitrogen trifluoride. Here we are asked to write the Lewis structure for Freon 12, also known as dichloro-difluoromethane, or CCl2F2, which is one of the chlorofluorocarbons responsible for the decomposition of ozone in the stratosphere. So to write the correct Lewis structure, we will first have to use the molecular formula to count the number of valence electrons in the molecule, and then use this to determine the skeletal structure for the molecule, and then distribute the valence electrons among all the atoms. And this will lead us to the correct Lewis structure. So we see here that the molecule has one carbon atom, and carbon, being a group 14 element, has 4 valence electrons, and we have 2 chlorine atoms, which is in group 17 of the periodic table, giving us 2 times 7 valence electrons, and we have 2 fluorine atoms, which is also in group 17, again giving us 2 times 7 valence electrons. Adding up all the valence electrons gives us 32 valence electrons in our molecule. Of all these atoms, we see that carbon is the least electronegative of the elements, and so carbon will be our central atom. Fluorine is the most electronegative of the elements, and so this will form the terminal atoms in the molecule. And then chlorine is also more electronegative than carbon, and these will also form terminal atoms in our molecule. The next step is to join the atoms in our molecule with chemical bonds, like so. And we should recall that in each chemical bond we have 2 electrons. And so we have in bonds 2, 4, 6, 8 electrons distributed. Next we will add our lone pair electrons. And so again we start with the terminal atoms. So we have 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 electrons. And so here we have distributed all of our valence electrons. We should note here that fluorine, which is one of the elements that must obey the octet rule, has 2, 4, 6, 8 electrons. And this is true for both of the fluorine atoms. Carbon also must obey the octet rule, and we have 2, 4, 6, 8 electrons for carbon. And so this is the correct Lewis structure for dichloro-difluoromethane. Finally, you'll note that even though chlorine does not have to obey the octet rule, in this case it does indeed have an octet, 2, 4, 6, 8 electrons. Here we are asked to write the Lewis structure for methanol, CH3OH, an important industrial alcohol that has been proposed as an alternative to traditional fossil fuels. Following the usual outline for drawing Lewis structures, we will start with a molecular formula and then use this to count the number of valence electrons in the molecule. And then we will write the skeletal structure using the electronegativities of each of the atoms. And then we will distribute all of the valence electrons among the atoms in the molecule, and then this will give us the correct Lewis structure. So we see here that methanol has one carbon atom, which is in group 14 of the periodic table, giving us 4 valence electrons. We also have 4 hydrogen atoms, which is in group 1, giving us 4 times 1 valence electrons. And we also have 1 oxygen atom, which is in group 16, giving us 6 valence electrons. Adding up all our valence electrons gives us 14 electrons to distribute in the molecule. The next step is to write the Lewis skeletal structure. And in this case, both carbon and oxygen will form the central atoms of the molecule, because in this case our molecule has more than one central atom. Now, carbon and oxygen are actually more electronegative than hydrogen, but because hydrogen can only have 2 electrons, hydrogen always forms the terminal atoms in a molecule. So here we have hydrogen as the terminal atoms, and the next step is to connect all our atoms with chemical bonds. And here we should remember that each bond is comprised of 2 electrons. So here we have 2, 4, 6, 8, 10 electrons in bonds. The next step is to distribute the remaining electrons as lone pairs. And the only place that can accept electrons is the oxygen atom, because we see here that hydrogen can only have 2 electrons, and each of the hydrogen atoms already have 2 electrons, and carbon, which must obey the octet rule, already has 2, 4, 6, 8 electrons. So the only place that we can place our electrons is on the oxygen atom. So we have 12 and 14 electrons. So here we've distributed all of our valence electrons in the molecule, and this is the correct Lewis structure for methanol. As I mentioned previously, carbon, which must obey the octet rule, has 8 electrons, and oxygen, which also must obey the octet rule, has 2, 4, 6, 8 electrons, and the hydrogen atoms, which must have 2 electrons, already have 2 electrons, 2, 2, 2, and 2. So this is the correct Lewis structure for methanol. Here we are asked to write the Lewis structure for ethylene, also known as acetylene, which has the chemical formula C2H4. Now this is one of the most important reactants in the production of polymers. We can see from the chemical formula that we have 2 carbon atoms, which have 4 electrons each, and 4 hydrogen atoms, which have 1 electron each. So adding up our electrons, we have 12 valence electrons to consider in our molecule. So we're going to start with the carbon backbone, the 2 carbon atoms, which are surrounded by the hydrogen atoms, which form the terminal atoms in the molecule. And now we connect all the atoms together with single bonds, giving us 2, 4, 6, 8, 10 of the 12 electrons that we have to distribute in our molecule. Now the last 2 electrons we're going to put on one of the carbon atoms as a lone pair. Now we see that the problem with this Lewis structure is that the carbon atom here, shown in the diagram, does not follow the octet rule. And what we can do to resolve this problem is move our lone pair electrons to form a double bond, giving us the correct Lewis structure for the molecule. In part B of the question, we are asked to draw the Lewis structure for nitrogen, which has the chemical formula N2. And this is the most abundant gas in the atmosphere. So the first step is to count the number of valence electrons, and we see that we have 2 nitrogen electrons, each of which has 5 electrons. And then adding these together, we have 10 valence electrons to distribute in our molecule. Now in this case, we only have 2 atoms, which we'll locate as shown in the diagram, and then we're going to connect those 2 atoms with a single bond. And we're going to distribute the rest of the electrons as lone pair electrons. And so here we have our 10 valence electrons. And again, we can see that the problem with this Lewis structure is that the nitrogen atoms do not obey the octet rule, as they are required to. And so what we can do is, once again, move our lone pair electrons to form a double bond, and the same thing for the other nitrogen atom, giving us a triple bond between the nitrogen atoms. And this is the correct Lewis structure for N2.